Now, when it comes to enterprises, a lot of enterprise teams are already running SBOMs and static code scanners. They feel like they have full coverage, but that's not the case. What does this assessment find at the JVM runtime layer that those tools completely miss?
You're right. So a lot of companies are already using SBOMs, they're already using static code analyzers. And the thing with SBOMs is that that's a supply chain security. And we've seen over the last few months, few years even, that there have been attacks on open source software where people have managed to get a pull request, a commit that's been taken on board, which has basically injected a vulnerability into an open source code base. And that's then propagated, because if you take something which is very commonly used library, that can then be propagated into other packages, other applications, and has a very serious effect. So SBOM is a very useful tool to minimize the amount of attack surface that you have in terms of those vulnerabilities. Similarly, if we look at static code analysis, certainly we've got static code analysis that we could run on the JVM itself and the JDK source code, but those tools from an end user perspective are much more about analyzing application code. So you've got this idea of supply chain management, you've got this idea of looking at end user applications, but there's still the issue of, in terms of deployments of Java runtimes, what are you potentially missing? Because neither of those tools are going to show you exactly what is the problem. And if I kind of explain what we're doing with this this runtime analysis, it's essentially saying, okay, you're going to have various Java virtual machines and JDKs installed on lots of different systems all over your estate. What we're going to do is we're going to look at all of those and identify which versions of Java you have running, even down to which update level you have. And then based on that information, we can look at all the vulnerabilities that have been identified and fixed in various updates. And by saying, okay, well, if you've got an update which was a year ago or 2 years ago, we know all of the updates since then, which vulnerabilities have been identified and remediated. We can then provide a list of the ones that you're exposed to in that instance because you haven't updated since a particular date. What we then do is we say, okay, let's run that across your entire estate, look at all the different Java installations you have, because they're going to be a wide variety of versions, updates, platforms, providers, all of those types of things. Bring all that information together into a centralized sort of dashboard view, which then allows you to see all of that information in a much more kind of digestible form, so that you can see, okay, I'm exposed to this number of vulnerabilities on this number of machines, this level of vulnerability, and so on. So it gives that sort of dashboard idea. You've got a sort of a high level view which you can provide to a CXO type of individual, whether it's CIO, CTO, CEO. Gives them a very clear picture very quickly of what your vulnerability exposure is there. We can also give you a risk by version breakdown, how many older versions you've got there, potentially ones that aren't even supported anymore. We've also got the idea of identifying any Java runtimes which have what are called KEVs, known exploited vulnerabilities. And these are where it's not just a vulnerability that's been identified, it's one that has actually been used to attack a system, which has resulted in a data breach or a denial of service or whatever. And then the last part that we give you from that is the idea of a prioritized remediation roadmap. And it's the idea that you can say, okay, if you had to address machines, you've got thousands of machines potentially, what are the ones you really need to go and hit first? And say, okay, these are the ones that need to be updated quickly because they're exposed to the most vulnerabilities. They may have critical vulnerabilities they're exposed to. There may be these known exploited vulnerabilities that are sitting there. So if you've got that list in a sort of prioritized order, you know where to start and then gradually work your way down that list.
And that's a critical gap. So how does these unmanaged and embedded JVMs sneak into production in the first place without security or platform teams even knowing they are there?
Yeah, there's a couple of ways that this happens. The first is simply the fact that Java is over 30 years old now. In fact, it's 31 years old. And that means that Java's been around for a long time, which means that it's been used to deploy applications for decades, literally decades. And that means that people have installed Java virtual machines and Java runtimes in different places to support different applications. And the people who did that may not even work for your company anymore. It may not be documented anywhere, it may not be recorded anywhere. So that sort of sneaking in is partly because the platform is so old that people have installed things. Similarly, when Java was completely free back in the days of Sun, in the early days of Oracle's stewardship, people would really just bundle it into a standard build, and they'd say, okay, well, there's a desktop there, let's just include a JDK in the desktop build and put it on every machine. But there's other things as well where people will go, oh, okay, I've got this application I need to run. Maybe it's a personal productivity application and it needs a Java runtime. So what they do is they just go to the Oracle website or to a website like Azul's, and they'll say, right, I'm going to download a Java runtime. It's free. I can just download it, put it on my machine, and off I go. And so unless there is something in place in an organization which tracks downloaded software, and I certainly know of people more recently who have done things like disabling the access to Oracle downloads pages through their firewall software, and even to the level of saying, okay, if you're downloading an Oracle JDK, they put the signature of that Oracle JDK into their virus software, and it will be detected as a virus. So there are various ways that the software can make its way into your estate without necessarily being spotted by the DevOps team.
Now, once you know what's exposed, you still have to fix it. And that's where a lot of teams get stuck. Mm-hmm. Enterprise teams are often terrified, or, not wrongfully, but they are terrified of patching legacy Java because they are afraid of breaking things in production. How does Azul's assessment actually help overcome that operational friction?
I think that when we look at that sort of situation, and I've certainly seen this with various customers that I've spoken to, where there is a reluctance to upgrade the Java runtime because there is a nervousness about it breaking application functionality. But the reality is that Java as a platform is very, very stable. I can certainly say, yes, there have been situations where we've seen that an update has come out and it's had an impact because it's included a change which has fixed one bug, but it's then resulted in another bug which has impacted other applications. So we've certainly seen that. There's no denying that, and that has probably led to some of this nervousness about implementing the updates. But I think the way that I would explain that is to say, well, if you have a very clear picture of what you're exposed to in terms of those vulnerabilities in your estate, and you look at certain applications, then you have to then evaluate the balance of how much risk you're prepared to accept in terms of doing an update, which potentially could impact the stability of your application, but that's going to be the case even if you installed an update to the application itself. So it's a little wrong to think that Java is going to be something which will break your application, but certainly it will give you a level of seeing what your potential is there versus the number of vulnerabilities you're exposed to. So if you're exposed to critical vulnerabilities, where it's like a 9.6 or a 10.0 on the CVSS scale, then what you're going to want to do is say, right, I really need to fix those machines. It's critical that I fix those machines because, again, going back to that log4j, log4shell example, if you haven't patched that, you're exposed to a very, very simple remote code execution vulnerability, which means people can take over your machine. That far outweighs the nervousness about updating your systems. So it's knowing that balance between what level of vulnerabilities you're exposed to versus the nervousness about updating your application runtimes.